We've spent the last few days talking about classes and other related topics, and we're not finished with classes or other data types. We're going to get back to those, but we need to divert a little bit and talk about some fundamentals, and not necessarily C# fundamentals, but fundamentals in programming. Now, we are going to focus on the C# implementation of those fundamentals, but these are things that can be applied to just about every language, the only difference being the syntax. What we are going to talk about today is making decisions. And this is very important because without decisions, we couldn't write meaningful applications. We could write some applications, but we wouldn't be able to make our application respond to certain criteria. And that's essentially what making a decision is. It's responding to criteria. But in programming, the heart of making a decision is called a condition. A condition evaluates to either true or false, a Boolean value, and then we can make a decision based upon that condition. So before we look at actually making decisions, we need to look at conditions because our decisions are based on conditions. So I'm going to open our program.cs file. And we don't need this code that we have used right now. We might need it in a few days. So I'm just going to comment it out. And I'm going to use a feature of Visual Studio. I have selected that code. I've right-clicked. And I'm going to go to Surround With. And there's an option here called Pound Region. And this is basically going to allow us to collapse this code into one line of code. And I'm just going to call this old class related code. And we can collapse this to one line, and this makes code a little bit easier to read. So if we have different pieces of code that we want to kind of hide away, we can do that whenever we want to with a region. And this has nothing to do with conditions. It's just a nice feature of Visual Studio to know about. Okay, so as I said, conditions evaluate to true and false, a Boolean value. So we can actually create a Boolean variable and assign the result of a condition to this variable. So let's look at some of the mathematical conditions. We have 6 is less than 5. So we are testing if 6 is less than 5. That is obviously false. So result should contain a value of false. Let's write this to the console and see. And it does, false. We also have a conditional operator. This is actually called comparison operators. We are comparing one value with another. So we are now testing if 6 is greater than 5. And of course that is true. We have greater than or equal to. We just add an equal sign to the end of it. Run it, and that is true. And we also have a less than or equal to, which is a less than sign followed by an equal sign. And that is obviously false. So these operators closely resemble the ones that we used in math. Now, of course, the greater than and equal to or the less than or equal to have a slightly different syntax, but the basic idea is the same. Now let's look at equality. And equality is not using a single equal sign because that is assignment. We are using that to assign the result of a comparison, a condition, and assigning it to a variable. So the single equal sign does not work, but a double equal sign is our equality operator. So it's going to test if one operand equals another operand. And whenever we run that, we are going to get false because 6 is not equal to 5. But we also have an inequality operator, which is an exclamation point followed by an equal sign. So we are testing if 6 is not equal to 5. And when we run that, we will see true. The equality and inequality operators can be applied to just about any type of value. So we can compare strings if we wanted. Let's do test is equal to test. That is going to be true. But if we change the case of one of those to a capital T instead of a lowercase t, then we are going to get false because those two strings are not equal. Strings can be a bit tricky because you have to factor encoding into the mix. Now with these simple comparisons, these are both encoded with the same encoding, so we don't have to worry about that. But if you are dealing with data that's coming from a database or user input or anything like that, you might have to consider encoding, and that's getting into more advanced comparisons as far as strings are concerned. And since we are on such a fast-paced course, we're not going to look at that. But it would be material for an advanced C# course, and if we do something like that, then we will dive deeper into string comparisons and encoding and all of that wonderful stuff. But while we are talking about strings, let's look at some of the helpful things that we have. The string class has a few what are called static methods, and we haven't really talked about static methods, but we will in a few days. But the static methods are methods that aren't on an object, they are part of the class itself. So we have a static method of the string class called isNull and this is going to return true or false based upon if the supplied string is null or empty. So let's just put in a string. This is obviously going to be false because the string test is not null or empty. So there we have false, and we have another window we need to get rid of. But if we get rid of the text and just have an empty string, that is going to be true. The string.empty is going to give us the same results, and null is going to give us the same results. So the isNull method is very nice to have. We are going to use it later today to validate some of the input that we get for our person class. We also have the ability to test against null. So let's do string str equals null. And change our condition, str equals null. That, of course, is going to be true. But whenever we give a value to string, even if it's empty, it's going to be false. We can also compare objects. Let's create a person object called Bob, and we'll just set him to null. We'll get rid of everything else. Is Bob equal to null? Well, absolutely. Is Bob equal to Bob? Absolutely. Let's actually create a person object. Bob is going to have a first name of Bob and a last name of Bob. Is Bob still equal to Bob? Of course. Let's create another person object. We'll call him Bob2, and he's going to have a first name of Bob and a last name of Bob. And let's compare these two together. This is actually going to return false because Bob is a completely different object than Bob2. It's not comparing first names or last names or anything like that. It's looking to see if Bob is the same object as Bob2. Now, we aren't going to cover it because it is an advanced feature of C#, but we can override the equality operator. We can write code for this operator so that it could look at the first name and last name properties of the two objects and return a value based upon that comparison. So we could write that code and result could actually return true because of the code that we would write. We could do the same thing for the inequality. We could write code to handle that. But since we aren't going to cover that within this course, we are going to do it the hard way. Well, it's not really hard, it's just the long way. We are going to take bob.firstname equals bob2.firstname. Well, we have the first name taken care of, at least that comparison. How do we compare the last name and use it in the same condition as the first name? Well, we have another type of operator, which is called a logical operator, and it operates on Boolean values. So we can use multiple conditions using a logical operator to determine if the overall condition is true or false. And I'm sure that that is clear as mud. So let's look at some code, because the code just always makes it clear. We are going to use a logical AND operator. And the logical AND operator works on two Boolean values. And the logical AND operation returns true if both of those operands are true. The logical AND is a double ampersand. So we have bob.firstname equals bob2 first name, we need to compare the last names as well. So with the logical and, all we have to do is then use a comparison of the last name. So Bob and Bob2 last name. And we can put this on 2 lines to make it a little bit easier to read. And we can also use parentheses to kind of surround one condition with another condition. So we have a logical AND operation here. And then on either side of this operator, we have one condition and we have another condition. And in order for the logical AND operation to return true, both of these conditions have to return true. So Bob.firstname has to equal Bob2.firstname, and Bob.lastname has to equal Bob2.lastname. Now we know that that's going to work, so this is going to return true. So if you were going to read this in English, it would say Bob's first name equals Bob2's first name, and Bob's last name equals Bob2's last name. That's just how you would say it, and that's how the condition works. And we can also call what's short circuit the logical AND operation. In order for this to return true, both of the conditions that it works with has to be true as well. So if the first condition is false, then the logical AND operation is false to begin with, because both have to be true in order for the operation to be true. So if we change Bob to Billy, then this is going to be false. And it's going to be false because the first names don't match. And since the first names don't match, it's not even going to bother with the last name. Just because with the logical AND, both of the conditions have to be true in order for the logical AND to return true. Let me type out all of the possible values of a logical AND operation. And I'm just going to use true and false because that makes it a little bit easier to read. So logical AND. And when referring to the logical AND operator and you're not using the actual symbol of the logical AND, it's always the capital AND for the logical AND. But that operator is 2 ampersands. So if we have true and true, the result is true. If we have true and false, the result is false. If we have false and true, that is false. And this is short-circuited. So short-circuit. And the reason why it short-circuits is because the first one is false. Since the first one is false, it doesn't need to look at the second. And last is false and false. And that is false. We have another logical operator called logical OR. Same thing, capital O and R. And it is a double pipe. That is our logical OR. And it works a lot like the word OR in the English language. You can like cake or you can like pie. Unless if you're like me, when you like both. And the result set of the logical OR is almost, well, it is almost the exact opposite. True or true is true. True or false is true. This is short-circuited. Circuit. And the reason being because the logical OR, either of the operands can be true. It doesn't matter which one. But as long as one of those is true, then the logical OR operation is true. And since the first operation is, or the first operand is true, there's no sense in evaluating the second one because the OR condition has been met. So it's true, there's no sense going to false, therefore it's short-circuited. So you can actually save some processing time by using the short circuits. If you know that there is a way to short circuit, if you have a value that could be true or false and you want to basically short circuit it, then you could do that. Okay, so we have true or false, we have false or true. That is true. And then we have false or false. And that is false. So with the logical and, both operands have to be true in order for the logical and to be true. With logical or, any of the operands have to be true in order to be true. Otherwise, it's false. So going back to our code, if we change this logical and to a logical or, the value of result is going to be true. Because even though Bob has a different first name than Bob2, Bob2 is now Billy. In fact, let's go ahead and change this to Billy. Now, something else about Visual Studio. You can see that there is just a little red rectangle. And this is a nice little refactoring feature. Whenever you change a variable, you can click on this little menu and it will say rename Bob2 to Billy, or you can rename with a preview. If you do a rename with a preview, it's going to show you all the places where it's going to replace Bob2 with Billy so that you can actually review where that is going to be done. In this case, it really doesn't matter because we haven't used it all that much and we don't have to worry about it. But you can at least see where it's going to change Bob2 to Billy. We can see Bob2 is listed here and it will change it to Billy. The same here. Bob2 is listed here and then Billy here. So if we click apply, it's going to change Bob2 to Billy. So now this makes a little bit more sense. We have Bob's first name equals Billy's first name. Now we know that that's not true, so this is going to be false. But remember that we have a logical or operation. So as long as the last name is the same, result is going to be true. So let's go ahead and run this, and there we go. We have true. We have one more logical operator, and it's called the logical not. And the operator is a single exclamation point. And unlike the and the or operator, the not operator only works on one Boolean value, and it reverses that Boolean value. So not true actually is false. Not false is true. And you might think, well, what's the use of that? Well, whenever we name Boolean values, we usually name them as, has something or is something. Something that as we are reading the code, it makes sense to be whether or not if a value is true or false. So let's say that we have a variable called hasValue. So the idea being that if hasValue is true, then it has a value. If it's false, then there's not a value. Now remember the is null or empty method for the string is null or empty. And once again, the name. If the supplied value is null or empty, then it's going to return true. Otherwise, it's going to return false. So if we pass in a string that actually is not null or empty, it's going to return false. And we are returning a false value to hasValue. Well, that kind of goes against what we have in our head, because if it's true, if hasValue is true, then it's supposed to have a value. So we can use the logical not operator here to reverse that value. So is null or empty is going to return false, but then we are going to reverse it with the logical not to true. So now hasValue is going to be true because we have reversed false to true. So that's essentially what the logical not operator is used for. Okay, so I think we've covered everything as far as conditions are concerned. We've looked at comparisons, we looked at logical operators, and now we need to make some decisions. So in C#, we make decisions using an if statement. The idea being if a condition is true, then do something. So we have if, and then we have a condition, and the condition is surrounded with parentheses. So an open and closed parentheses, and then we put our condition inside of that. I'm going to be very simple and just put true. And then we have a code block. So anything is going to execute within this code block if the condition is true. And we have hard-coded it to be true. So let's just do console.writeLine. This is true. And that's obviously going to take place because we have hard-coded this to be true. Now, what if this was false, though? We would want to do something if this was false. So let's make that false. We could have done if false, but the logical not was a lot easier. If this is not true, then we want to do something as well. And that is why we have the else statement. And like the if, it has a code block, and anything inside of that code block is going to execute if the condition is false. So let's copy that line of code, and let's say this is false. So whenever we run this, we will see this is false. Now you can see that Visual Studio is giving us a little green squiggly, and that is because it recognizes that this is unreachable code. Because we have hard-coded this to be false, we will never get to execute this code because this only executes when it's true. If we change that to true, we are going to see this switch here, unreachable code. Why is that? I guess we have to build it first. Yeah, okay, so after building it, it recognizes that we can get here, so the green squiggly goes away, but now we have a green squiggly here because we have hard-coded this to be true. This will always be false. So let's actually not hard-code this so that we can see something. Oh, we don't want var yet. We haven't gotten there. But you can use var, but we're not going to. Okay, so let's have a variable. I'm going to call it str. Whenever I just have a generic string, I usually call it str. And let's give it a value of test. So let's say if test, or if str equals test, then do this. Otherwise, do this. So this is obviously going to say this is true. But if we change this to if str is not equal to test, then do this, otherwise do this. Now this is going to be false because we are seeing if str is not equal to test. So that is false. And we will see this is false. Now there are times when we want to do multiple cases. Like for example, we have one condition here, but if this is false, we might want to evaluate another condition. If we want to compare str to several different strings, for example. So let's change some of these. And all we have to do is do an else if. Instead of else, else if. And this will allow us to evaluate another condition. So let's say lowercase t, uppercase e. We need to change this text. This is second true. And then we can keep going. If we wanted to do another else if, we could do that just fine. We can put as many else ifs as we want to, but for the sake of time and brevity and simplicity, I'm just going to do an else. This is false. So what happens here? Because we have a value of test, all lowercase, we are first going to evaluate this first condition. The lowercase test is not equal to this version of test because it has an uppercase T, so this is going to be false. So this code will not execute because this condition is false, so it's going to go to this next condition, and it's going to compare the variable with this string, and this is also false. So this code will not execute. It will go to the else statement. So in this case, the else statement is kind of a catch-all. If all of these conditions fail, we are going to get to the else condition. And we don't have to have an else. I mean, we might not want to do anything at all if all of these are false. But most of the time, we do want to do something. So because all of these conditions failed, we will get to the else, and we will see this is false. So let's run it. There we go. This is false. Let's change the value to have an uppercase E, and now we will see this is second true. There we go. And it's important to know that whenever we get out of this if else statement, code execution continues on as normal. So let's say we're out of the ifs. So in this case, this condition is going to be true So we are going to execute this line. Well, since that condition is met, it's not going to go to else. It's just going to go right on to the next line after the whole if else statement. So here we have, this is the second true, and then we're out of the ifs. The if, else if, and multiple else if, this type of approach is handy if we are comparing multiple values with other possible multiple values, if we have different conditions, in other words. But in this case, we are trying to find a match for just one value, the str variable. And in that case, we have an easier way. Well, it's not necessarily easier, but it's easier to read and easier to maintain, because if we have multiple of these else ifs, things can kind of start to run together. And of course, I didn't change any of these conditions, but even just minor variances are difficult to keep track of, just because that's the nature of if and else if. So we have a different statement that we can use if we just want to compare one value with another, and it has to be an equality comparison. It cannot be a less than or a not equal to or anything. It is basically to take a value and to find a match for that value. And that is using a switch case statement. And we start that with the keyword switch, and then an open parenthesis, and then we put the value that we want to test for. In this case, it's the variable str. And then there's a code block. And inside of this code block, we have what are called cases. And we can have as many cases as we want, but these are basically going to be the tests for the matches to find a match for our value here. And we use the keyword case, and then we specify the value. So let's do test in all lowercase. And we don't have a code block with a case statement. Instead, we have a colon, and then break, and then a semicolon. And anything in between the colon and the break is going to execute if a match is found for this particular case. So we can do console, write line. Let's use a verbatim string, and let's say the value is test. And then we can simply just copy this, and we can have multiple cases. So let's do a capital T, let's do a capital E, and let's do one more with a capital T at the end. Let's make sure that we have specified what those values are whenever we write that to the console line. Now, what if we don't find a match? And of course, we will find a match because we do have that value within this case. But let's say we don't have that value, and we want to specify kind of the else statement, the one that's going to execute if there is no match found, or all of these comparisons are going to be false. And for that, we have a default case, and it doesn't use the case keyword, it uses default, followed by the colon, and then it ends with a break. And then we can just simply say console write line, no value was found. So if we execute this, let's go ahead and change this. We are out of the switch case. So whenever this switch executes, it's going to switch between all of these cases based upon the value that we have specified here. So it's going to look at the first case. It's not going to find a match, so it's going to look at the next case. It's not going to find a match, so it's going to go to the next. Not going to find it. Not going to find it. And then since it went through all of these cases, didn't find a match, it's going to go to default and say no match was found. And there we go. So let's change the value to something that we do have a case for. Run it. And there we go. And it's important to also note that whenever it finds the case, it's going to execute that case and then exit. So if test is all lowercase, it's going to find a match here with this case. It's going to execute this console write line statement, and then it's going to break out of the switch statement. So it's going to immediately exit the switch case statement and then go to console.writeLine. And there we go. So that's basically all we have to do for making decisions. Of course, this is a very simple decision based upon equality, but we also talked about the other comparison operators, comparing numbers together as far as less than, greater than, or equal to. And then we also talked about the logical operators that worked on Boolean values to make more complex decisions. If this and this are true, or if this or this are true, or if this is not true, or things like that. So that is how we make decisions. And tomorrow we will apply some of this information to validate the input for our person classes constructors and say hello methods. So with that, I will see you tomorrow.